Hello and welcome to another video. In this one, we're going to be talking about the open function, specifically during tests and how you would go about mocking it using monkey patching. I previously did a video on monkey patching. You can search my channel for that one instead. We're actually going to start with a bit of pre-written code. I usually don't like to do this because we'll write it live, but I needed some sort of non-trivial example, and so I wrote up this small program. I guess we'll start from the main function. It's a silly program, but it's going to take an argument to greet someone. It defaults to user, and it's going to print hello. But specifically, it's going to read the thing that it's greeting you from a config file, which I've implemented as load config here, which produces this config object. You can pause and read the code if you want, but it's still pretty straightforward. But the point of this, the reason I've written it this way, is we're using the open function and we want to be able to test this code. We want to be able to write a unit test and validate that it works correctly. Note that I've also put a config file here where the greeter is computer, and if we run this, and we can specify the thing to hello. And you can see it works. Well, you can see it works by manually running it. However, we don't really know that from a automated test suite. So we're going to write an automated test suite for this. And specifically, I'm going to show you how to mock this open function. That's the goal of this. All right, let's write a test. Well, I guess let's install PyTest first. Pip install PyTest so we can show what version we're using. 9.0.3. Nice. And if we make a test file for this, we're going to do from t import main, and we're going to test greet. Let's just start by writing a test and seeing whether we can get it to work or not. The first obvious problem is we don't really have a config file other than the one that I wrote out there, and obviously that's not going to be what the user is going to use for this. They're going to have their own config file, and so that's kind of the first weirdness here. Is how do we make sure that that config file is exactly what we want? So let's actually just call main. We're going to use a fixture called capsys. This is going to allow us to capture the output, and we also don't have a user set here, so that's another problem that we're going to run into. Fortunately, if you don't pass it, it'll default to the one that we're running, but we'll see all those problems in action, and then we'll go about fixing them. Also note that I probably wouldn't go about testing this code in the way that it's written. I would probably refactor it so that it's more testable. I'll show you that at the end as well, and we'll completely avoid the knowledge that I'm teaching you in this video, but that's fine. But somehow we want to get to assert capsys.readoutError.out is equal to hello person from greeter. That's what we want to get to eventually, and there's a single quote at the end of this line that you can't see behind my cameras. But let's run the test and see what's failing and then try and get to things working here. All right, so the first thing that we run into is that argparse is crashing because we don't have the arguments that we're passing here. And in fact, we're getting the arguments from the PyTest invocation itself. So we get this kind of weird usage error from PyTest. Obviously, it just inferred this from argv0, and it's not actually our program. And this is because we're not passing the arguments that we expect to this program. Actually, the very first explains video on my channel, I believe, well, if you ignore 000, is about this particular idea, which is we want to be able to pass arguments into our program here such that we can test it properly. And the easiest way to do this is to take argv, which is a sequence stir or none defaulted to none. Let's import sequence up here. Actually, it'll be from collections.abc. I gotta get into the habit of that. Of course, if you're using PyUpgrade, you can do this and it'll just fix it for you. But also, yeah, I'm putting only one space in here so you can see more of the code at once. And we pass argv into here. So this has the nice pattern in that if you call it with no parameters, such as what we're gonna do here, it'll depart. That's a funny way to say that. It'll default argv to none, and it'll grab it from sys.argv1:. But otherwise, if we want to pass this a particular set of arguments under test, we can force the value here. So it's a nice way to sort of inject the program arguments here. So we can go back to our test here, and now we can fill that part out. So we can say hello is person, since that is what we wanted to validate here. We probably also want to assert that this returns 0, just to say the program was successful. And so let's run this test again. And you can see here that we're getting a failure here. In fact, it's reading that config file that I wrote on disk. So if we actually move that config file out of the way, we can see that no such file or directory config.json, which is not what we want. We want to actually be able to use or pretend that there's a particular config during this test, and we need to be able to mock the open function for that. Now, in order to mock the open function, we need to be able to target it so we can replace the implementation out. And it technically lives in sort of two places here. I'm going to show you the more blanket one. The kind of fun part about all of the built-in functions is they live in this module called built-ins. And you can see the list of them. There's many, many of them, but one of them, the important one, is the open function here. There's also the print function as well if you wanted to mock print. We're actually avoiding mocking print by using capsys instead as a way to sort of grab the rest of the output. But we're going to be able to mock this open function. You could actually just, builtins.open is equal to whatever you want. I don't know. Now, if I called open foo, it's not actually going to be opening a file anymore. It's returning a string because I've monkey patched the built-ins module. Obviously, you don't really want to do this because it sort of breaks Python in funky, weird ways, but we're going to be doing it temporarily under test so that we can validate that things work correctly. And so let's start doing that. T-test.py. We're going to import the built-ins module, and I'm going to import from unit test import mock. This has a bunch of monkey patching utilities that are useful during test. You probably shouldn't use them during runtime, but I've definitely worked at places where that happens. And we're going to use mock.patch.object. I strongly recommend always using mock.patch.object. There's some fiddly bits with the mock.patch with a string, but that'll be for another video. With mock.patch.object, and we're going to patch out built-ins open. I'm going to show you the other target that we can use here. We can actually use a different target instead of built-ins if this is scoped too widely, specifically because this will patch open for the entire process and not just the particular module that we're testing here. And so this sometimes breaks other weird things in weird ways, and so I'll show you that in a second. And let's just start with this so we can see how this works. And how we're going to have to be a little bit more clever about how we patch the target of this patch. So let's start with this. The test should still fail, but you'll see here, well, actually we get further on, we get to a type error where we try and load the JSON and we get this magic mock error. But let's actually put a little breakpoint. Let's do -pdb. This will drop into a debugger when the test fails, and we can actually poke around and see what has happened up until that point. So you can see this is our crash here. We're going to actually hop out of the JSON code and get back to our test here and look at this mock. And we want to, what is it? I forget what that little attribute is. Mock calls. That's what I was looking for. And so we can actually look at how this particular mock object has been called during our test. And you'll notice here that it's not just calling it the open function with config here, as we see in our file here. It's not just this open function here, but this with statement is implicitly, well, sort of explicitly, but sneakily calling double under enter and double under exit eventually. Yeah, so double under enter and then the read function of that double under enter. So the way to read this is like, this is the initial call, this is the return value dot double under call, and then the return value dot double under dot read call. And so you kind of have to be a little bit more clever about how you're mocking this object such that you actually produce the red values that you would want here. So there's a little bit of fiddly bits here to make that happen. Fortunately, the standard library gives us a helper for this that makes it really, really easy. There is a mock open helper here that we can pass in directly. So we can say mock new equals mock open, and I believe it's read data. Let's give it some JSON. Greeter. And so you can pass this as the mock in here. And this handles that double under enter and double under exit and read functions for us. So we don't have to deal with that. I actually personally don't really like using that, but it works all right. Oh yeah, mock.mock open, obviously, because I imported the module, not the attribute. And you can see our test now passes. We've forced greeter to be this by mocking open here. We've forced the person to be that from the argument list. And we've validated our output here. Now I did mention that there's another target that you can use instead of built-ins, and that is to use the module under test itself. So we're going to import the module itself and patch that here. This might be useful if some other third-party library needs to use open in some way, and you can see we're able to patch that in this way. One other thing that you can do, because sometimes this mock open isn't as good as you would want it to be. For instance, like I think it fails as instance of IO subclasses, and like it doesn't have all of the methods that a file object has, and so sometimes this isn't quite what you want. But you can do sort of what you would do here, but use an actual fake string object or string IO object instead. And so the way you would do that is do this as mock, and then say mock dot return value dot double under enter dot return value equals new, and you'd set new to instead be an io dot string io of this contents. And so this allows you, this is the kind of shorthand for what mock open was doing for you. I don't know why they don't just use a string io under the hood. Maybe they do, but it seems like not given the documentation. So anyway, this is another way to do this. PyTest, t-test. Let me make sure it actually works. Yeah. I tend to lean towards this because it feels more natural to me. You can also do all of this directly in this single call here. It's a little bit fiddly though. Let's see if I can get this right on the first try. You have to pass in this as a keyword argument, but obviously you can't have dots in a keyword argument. But you can fudge them like this. And the mock module sort of knows what to do here. This looks wrong. It is wrong. Oh, right, because it's not mock.return value, it's return value dot, yeah. It's obviously a little bit weird to pass a non-string keyword argument via ***, but it does work. Okay, and so that's kind of mock open. For writing files, you have to get a little more clever. You'll patch in the same way. You'll patch this object out here, but you'd have to adjust how your write file or your write attributes work. This is obviously more for reading than for writing. Writing gets a little more complicated, but the same basic idea applies in that you're going to be targeting the object here. Now, I'm going to talk about what I would probably do in this case to make this a little bit more testable and not need mocking at all. And it kind of boils down to the same idea of what we were doing with argv here. So one nice extension to this program might be that our config file is customizable. So let's say that we have argument --config. Obviously, we still want to default to that config.json that we had before, so we'll do that, config.json. We also have this load config function. This kind of has sort of two problems here. Like one, it's just kind of guessing at the config file. It's hard-coded here. The first improvement could be to take the config file as an argument, but it might even be better to just take the file object itself. Then you could test this directly without needing to actually invoke the file system at all. So let's actually do that instead. We can say f is an io stir. I think there's probably I forget whether this guy moved or not, but I know it used to be there, so we can do that instead. And so now rather than actually opening the file here, we can isolate all of the side effects directly into here. Obviously in our main function, we now need to open that file with open args.config as f. So now what we can do is we can directly test the both the position or the file on disk of config, but also we can test this function directly without needing to invoke any file system stuff. Our test should still pass here because we just did a refactor here. But let's show how we can write this test a little bit better now. So instead of having to mock here, we can instead use a temporary file system, so temp path, and say that config equals temp path dot join path myconfig.json and config.write text. We're gonna write this text directly into that file. Don't need to mock anymore. We're just gonna pass in our config now. Dash config this. And so now we've, completely isolated out mocking. We don't need to do any of this built-ins or mock or T anymore. We just are really using basic file system stuff and using real values. I think, hopefully the takeaway here is like using real values gives a much more realistic expectation of how the code's actually going to run. And then you don't have to deal with all the fiddly mock bits. So that's probably how I would refactor this program. You might even test the load config function directly. And obviously I'm not going to bother with this, but you would use like io.string.io and pass it into your load config function. Then you could validate if you had any complicated business logic there. Obviously in this silly example, there's no complicated business logic. It's literally just load an object. But anyway, hopefully that was instructive, how we made it easy to test arguments. We made it easy to test a custom configuration file. We were able to mock open, and even after the refactor, our original test still passed. And this made the code slightly more testable by moving things around. But anyway, I hope you found this useful. If there are additional things you'd like me to explain, leave a comment below or reach out to me on the various platforms. But thank you all for watching, and I will see you in the next one.